We couldn't have done this 2 years ago. I feel like so many pieces of the puzzle are now coming into place where people can really very easily, with an hour's worth of work, measure the emissions of a piece of software. Basically, the dream world I have is in 6 months' time, thousands of open source repos all over the world just drop a configuration file into the root of their repo, add a GitHub action, and they're measuring an SCI score for their product.
Hello, and welcome to Environment Variables, brought to you by the Green Software Foundation. In each episode, we discuss the latest news and events surrounding green software. On our show, you can expect candid conversations with top experts in their field who have a passion for how to reduce the greenhouse gas emissions of software. I'm your host, Chris Adams. Hello, and welcome to a special mailbag episode of Environment Variables. This is our second installment of the format where we bring you some of the questions that came up during the recent virtual event hosted by the Green Software Foundation on World Environment Day back in June. If you missed our first episode from this mailbag format, feel free to jump back when you'll see some of the other questions that came up and some of our eloquent and possibly not quite so eloquent answers as we ran through that. Today, we're going to run through a few more questions. And as ever, I'm joined by Asim Hussain, Executive Director of the Green Foundation. Hi, Asim.
Hi, Chris. How you doing?
I'm not too bad. Bit grey outside over here in Berlin, but otherwise not too bad, really. Okay, before we dive into this, the questions we'll run through. If you're new to Environment Variables, every time we record one of these, we share extensive show notes with all the links to the papers and the sources and the things that we do have. So if any of this has piqued your interest, there will be a link that you can jump into to basically continue your nerding out about this particular subject. And I think that's pretty much it. But before that, actually, maybe we should introduce ourselves, actually. Asim, I've introduced you as the exec director, but I suspect you might want to say a bit more about the Green Software Foundation, what you do, what else you do when you're not working at the GSF.
Yes, I'm the executive director of the Green Software Foundation. I'm also the chairperson of the Green Software Foundation, so I hold both roles right now. Yeah, I've basically been thinking about software and sustainability as Chris for quite a few years. Outside of the GSF, I'm also the director of green software at Intel, where I try and work through an Intel strategy regarding greening of software and helping there. Because, the only people who buy stuff from Intel are people who run software.
Thank you very much for that. We will have this and better revelations and more insightful revelations coming ahead.
Yeah, gets better than this, people.
Yeah. My name is Chris Adams. We're a little bit Monday this morning, it seems. I work at the Green Web Foundation, which is a nonprofit based in the Netherlands, focusing on reaching an entirely fossil-free internet by 2030. And I'm also a maintainer of a library called CO2JS, as well as being one of the chairs of the policy working group inside the Green Software Foundation. I'm also the regular host of this podcast specifically. Should we dive into these questions for the mailbag?
Yeah.
All right.
Let's go for it.
Okay. All right. So the first question that came through was one about the SCI. The question is, this SCI is not capturing energy consumed by memory, I/O operation, network calls, etc. What is your take on it? This is a question from the World Environment Day thing. This might be a chance to explain what the SCI is, because as I understood it, it does capture some of that stuff.
Yeah. My answer on the day would have been like, huh? Yeah, it does. Or something a lot more eloquent than that. But yeah, the software carbon intensity is a specification being built by the Standards Working Group in the Green Software Foundation. It is almost in ISO. That is our goal for this year, is to we're really going through that process.
And just to jump in, ISO is the International Standards Organization.
Yes, that's the one. Yep. And what it is, let me just very quickly say what it is. It is a method of measuring software carbon intensity, which is a rate. If you listen to a podcast, it'll probably be carbon per minute of the listen. It's a rate rather than a total. Other kind of really standout aspects of it are that it's been designed very much by people who build software. And so it's been designed by people who actually build and measure software to act as a good metric to drive reduction. So it makes sure that inside it is included aspects so that if you did things like move your compute to a greener region, or you move your compute to a time when it's greener, or things like that actually would be recognized in the calculation. Whereas, for instance, if you use the GHG protocol, oftentimes stuff like that isn't factored in And you can do carbon rate computing till the cows come home, but it wouldn't really affect your GHG score. There's some of the aspects of the SCI. It's very, very much built that way. Now, what I will say is if you actually look at the SCI equation, it's very simple. You basically, per R, so it's always what we call per R. So per minute might be the R, or per user might be the R. So per R, you have to figure out how much energy is consumed. You have to figure out how much, what we call embodied carbon, so how much hardware is being used. And if it's per minute, then you figure out how much energy consumed per minute. If it's per minute, you just try and figure out how long is this piece of hardware normally used for and divide it by enough so you get per minute. Then the other thing you also factor in is a thing called I, which is the grid emissions factor. So how clean and dirty is your electricity, and you're factoring whatever it is for that period of time with electricity. And the key thing there is that's it. And so therefore, it includes everything. It doesn't exclude memory or IO or network because it's energy in hardware and the grid emissions. And so as long as you've got some values for that, for your memory, for your IO, for other things, you can do it. What I will say to answer, I don't think this was in the spirit of the question, but I think it's related to it. Measuring is hard. It's really hard. Like Chris, you've got CO2JS, and that does a great job of kind of network. But even then, you have like multiple flags. If you want to use it in this mode or this model or this assumption, like I use it all the time these days. What did you say? Like all models are bad, some are useful. Yes, I do think that calculating an SCI score, which includes memory, IO, network calls, all the other factors in software, is challenging, and I will acknowledge that. But it's also something that a lot of people are working on, and I think we're working on that with things like the impact engine in the foundation, and Chris, you're working on it with the CO2JS. RNA is working on it from Green Coding with those models. Yeah.
With GMT, the Green Metrics Tool. All right, that's your answer.
Yep.
Hopefully that should give plenty to refer to. I'll add a couple of links to what this SCI is to make that a little bit clearer, so for people to understand what that might be for that question. Should we jump on to the next question, actually, Asim?
Yeah, sure. Yeah.
Does the GSF have any real examples measuring the SCI on pipelines of CI/CD? That's a soup of different letters there. But as I understand it, the GSF being the Green Software Foundation, SCI being the software carbon intensity is a way to measure the carbon footprint, and CI/CD being continuous integration, continuous delivery, like automating the process of getting software out for people to use. All right?
Yeah.
All right. So now that we've explained what the question meant and unpacked some of those all those TLAs, three-letter algorithms, do you want to have a go at this one? Because I can add a little bit myself with some recent work that we've been doing. In my day job.
Yeah. So definitely, I'd say there's two things. Is that a lot of work that goes on is also just behind closed doors as well, and that's one of the things that I find interesting about this space, is that sometimes you'll just never hear of it. So in terms of real examples of measuring SCIs, so there's a project called the SCI Guide, which has a number of case studies inside them where organizations are really trying to document what they're doing and revealing the numbers. Revealing numbers is very challenging for a lot of organizations. I can attest to it. You have to go through so many levels of approval to reveal your numbers. So we've only got a couple of examples of those. But there's definitely tooling that we're building to make this a lot easier. So we're building something called the Impact Engine Framework, which is a framework, which is what Carbon QL is now called, the Impact Engine Framework. So if you've heard me say the word Carbon QL, it's now called the Impact Engine Framework. And it's a tool with a manifest file, and you can use it to calculate the emissions. And you can say, I want to use CO2JS, I want to use carbon footprint, I want to use green metrics, and you want to use whatever. And it helps you measure an SCI score. And where we're starting to think now is we'd like to get to the point where there is a GitHub action. Basically, the dream world I have is in 6 months' time, thousands of open source repos all over the world just drop a configuration file into the root of their repo, add a GitHub action, and they're measuring an SCI score for their product. It's been 2 years now in the making of even the specification. We couldn't have done this 2 years ago. I feel like there's so many pieces of the puzzle are now coming into place where people can really very easily, with an hour's worth of work, measure the emissions of a piece of software. And that's where, the CI/CD thing is coming, I would say, in 6 months' time, at least from our side. And it sounds like you've already got some work anyway from the green coding landscape. Yeah.
Yeah, I actually didn't know about the impact engine, that's new to me as well, actually. Yeah. The thing that we've been using, so with my day job, one thing we've been doing with a open source project called Wagtail, we've been working with some of the core developers there, and on the Google Summer of Code, a couple of early career technologists who I've been mentoring to introduce some essentially like green coding features into Wagtail itself. Now, the last release of Wagtail came out in, I think, beginning of August, actually, the end of July. Now, Wagtail is a content management system, a bit like WordPress, but unlike WordPress, it's written in Python, and it's actually written on top of a software library called Django, which is what our own platform uses. Wagtail was used by a number of websites with NASA. If you visit the NHS website, you're using a Wagtail website. There's a number of ones that it's in use in. And what we've been doing is we've got chatting to the folks at Green Coding Berlin, which is pretty self-explanatory what they do green coding, and they live in Berlin. And we got chatting with them about this because we were trying to understand, okay, if we're going to make some changes, are we going to be able to understand the environmental impact are we making progress? They also have a very literally named tool called the Green Metrics tool. Can you guess what the Green Metrics tool does, Asim?
I don't know, man. It's hard with these terms. Does it generate green metrics in a tool?
Oh, dude, it's so German. I live in Germany. This is like to see these.
What's it in German? Say it in German.
No, we don't actually have okay. The Green Metrics tool is what it is in German as well. Right, okay. So I think GMT is what we end up referring to it.
That's quite funny.
To say.
Greenwich Mean Time. Cute. Yeah, Greenwich Mean Time.
Exactly.
Well. Yeah.
We've been using that, and the thing that I think is quite interesting about what the folks at Green Coding Berlin have been doing is they've realized that, okay, there's a bunch of open source tools, open source software in the world. So they've been basically forking a bunch of open source tools, running this. And then whenever there's a kind of CI run, they've been measuring some of this. And they've actually got a project called EcoCI, which basically is like a GitHub action that measures the power used when you do a kind of run, as it were, a CI run to test something. So they've got some of these figures here. And the thing that they've been doing, which we found quite useful as well, is they've been using a tool which allows us to run through common scenarios. Like I go to a website, I browse to a few places, I search for something, I submit a form, I upload, something like that. We've got a set of journeys that we follow, and we're using those as the kind of sample ones as our kind of baseline to see, is the work that myself and Aman, the student I've been working with the most, is the work that we've been doing there, has it been helping or has it been not helping? Because the particular piece of work that we've done recently is introduce a support for a new image file format called AVIF instead of just using like JPEGs, and massively typically halves the size of any of the images that you do use. But there is a bit of a spike in energy usage compared to what you would use both on the server and on the browser. So we're now actually trying to run this in various scenarios to see, is this actually an improvement on us? Because even though it results in a nicer experience, we're trying to make sure that we're going in the right direction. So that's one of the things we have. There's a couple of other things we have going on as well, but that's the kind of most concrete example that I might refer to. And there's a couple of links to both the output from this, but also the open source projects, because you can mess around with some of this stuff pretty much right after this podcast if you really decided.
So this is the stuff that is using direct measurement. So you're forking it, running it on like a special rig that is like measuring it. Yeah, I think it's interesting. I feel like this is like something that's been in discussion with the SCI as well, but we never landed on some good terminology for it. I think we use measurement versus calculation. And we tried to say the word measurement meant like direct, like what's happening in green coding, like direct measurement, something from counters or from a power meter or something like that. Whereas we use the calculation is when you're just taking some sort of, we call it now in the impact engine, for instance, observations. You take some observations about a system and you're passing into a model and getting an estimate of emissions. So I think the language here has got to get a little bit more specific. I remember on the calls, we were even asking academics whether there was like specific language around this, and there wasn't. Maybe one of the listeners can say, actually, Asim, what you're describing is the word for calculation is X and the word for measurement is Y. This is where we're getting to. And I think this is where the conversation is in this kind of generally metrics area. One of the reasons I'm exploring modeling is actually for a very interesting use case, which is once you model, you can simulate. So once you've got a model, you can then tweak the model and say things like, so one of the things we're exploring is like, what if you were to change some aspects of the system? You've got a model. So can you then model that change and then estimate the emissions reductions? And that's where like modeling has an advantage, or modeling has a real disadvantage in the fact that it's a model and you're not really going to get a great actual measure. So I'm not too sure. We don't have the answers. I just think this is an interesting question. It's like measurement versus calculation. And I haven't fully formed my thoughts on this yet as well. But I think it's going to be an active bit of discussion for a while. Maybe it has been an active bit of discussion. Maybe I'm just really late to the conversation.
I'm not sure myself, to be honest. We'll need to see. Yeah. The thing I can be relevant. So when we were using this to figure out whether we're making things worse or better inside Wagtail, I asked Anna about some of this. Okay, how are you actually coming up with these numbers? And they basically do things. Yes, they have a rig where they've got like a bunch of machines that they have where they're reading the data directly from that. But they've also been doing a bunch of work with some of the underlying data that's published by various chip manufacturers. Something called the spec power. Yeah. And I've shared a link which basically goes into stultifying amounts of detail about what they do. They've spoken about, okay, this is the tool that's used by Green Pixie, by Cloud Carbon Footprint, by Teads, like a French advertising company who've been trying to figure this stuff out. And they've basically shared their modeling of it, which could presumably be consumed by Kepler as well. So they're trying to build these models because they don't have access to the underlying data. And this is something we spoke about in the last episode and the previous episode before that about why it's a real challenge to get these numbers from especially large hyperscaler providers who basically would really like to have much more control over the language. And in many cases, they give honestly quite good reasons for saying, look, share these figures, but they citing reasons like commercial confidentiality or an attack vector. This is why I'm quite excited about the real-time carbon project, because it's a chance to finally
get value
past some of that. So you can actually have some meaningful numbers. So you can say, are we making it better or are we making it worse? Because even now in 2023, getting these figures is a real challenge if you're not running your own hardware.
Yeah.
And I guess, Asim, now that you're working at a company that makes the hardware or makes much more of the hardware, that's a different change for you now. You see more of it from the other side, right?
Yeah, I do get, and I speak to a lot of people now. And in fact, actually, one of the things that maybe would be useful to have a deep dive on spec power, if you want to have an episode, I could definitely bring some people. There's one of the people in my team, she's been spending a lot of time really getting into the weeds. And it's fascinating working with people who build CPUs their entire life, because it's a different, like you think, Chris, we just write some variables in a Visual Studio Code every now and again and claim to understand technology. Once you really get onto the CPU, there's a lot going on that we are so abstracted away from. And like one of the conversations happens all the time inside Intel is like, how do we close that gap between what developers are doing versus what the hardware can do to be more efficient? And I think there just sounds like there is just this chasm of opportunity here, which we're just not taking advantage of. A lot of the stuff that's happening on the Intel side of the equation is just making people optimize their code, but using standard kind of optimizations that have been available for ages. And there's a lot of just understanding that I don't even understand how a CPU works sometimes. Like the energy curves just do not make any sense to me. I'm not going to go into depth as to my lack of knowledge of what CPU is, but I could definitely bring people in who are much more knowledgeable than me. And then maybe let's have a deep dive into that. That'd be fascinating conversation. Like really get into a chip. Actually.
Yeah, because the thing we're seeing from the outside, or the thing I've noticed from the outside, and I've seen other people also referring to, is the fact that, you know how we had this thing back a few years ago where engines had like defeat devices where if they're tested, they're going to work a certain way, and they really are. It turns out that you often see some patterns a bit like that whenever you have benchmarks, because if you design for a benchmark, it might not be designed. There are scenarios where a chip will work a certain way that will make it look really good in the benchmark, and that might not necessarily be how it actually works in the real world. Basically, you got that happening lots of cases. I would really love a deep dive into that, because this is the thing we struggle with, and it's weird that say most chips are most efficient are like at 2/3 capacity, between 2/3 and 3/4, right? Rather than, so you might think like you got, if I turn it all the way down, that will turn all the power down. No, it doesn't work like that.
Yeah.
And there's all these other incentives about where you move computing jobs as a result, which has this kind of knock-on effect. All right.
There's also really interesting work around, like when we talk about moving compute around different parts of the world, there's actually a really great project, being open source project run through Marlo Weston, who's my colleague at Intel, which is also one of the chairs of the CNCF environmental tag. And I'm going to get the name of her open source project wrong. I think it's Kubernetes Power Mode. And what it does is it does like load shifting across cores on the same CPU. So normally when you like, you want to max out one core before allocating work to the other cores. That's the most efficient way to go up the curve. But most like allocators will just allocate them across all the cores on average. And so she's built this kind of Kubernetes scheduler, which basically will max out one core at a time till you get to the top.
Wow, I didn't know that was possible. That's a bit like how cars. So certain cars would be, if you got a car with maybe a V8 inside it, there are some cars which will basically just run on 4 of the 8 engines, 8 cylinders firing, all 8 for fuel efficiency. That sounds like the kind of cloud equivalent to that idea.
But there's also,
really cool.
But she's actually got a second Kubernetes project, so I'll get the link to, which allows you to change the clock frequency of your chip at the application level. So with the intention of, if you can change, people talk overclocking. You can actually underclock. And underclock actually does this amazing thing where you get much more efficient from an energy perspective, because everybody's looking at like reporting what is the like peak level efficiency. But if you can just say, look, I'm willing to run at 20% less clock speed, you actually gain more than 20% energy efficiency improvements, but you lose out on the performance. So if you can dynamically change the clock frequency, which happens a lot on like laptops and mobile devices, does not happen on the cloud space. Has lots of negative consequences as well. You really can't just do it without knowing like how an entire stack works top to bottom. Yes, a very advanced piece of thing. But if you can take advantage of that, there's additional efficiencies. Again, reducing that chasm between what we developers think we know about tech and the hardware versus what hardware actually does is, I think, one of the frontiers of this space.
This was actually something Arna explained to me. He was looking at why some of the figures that say, we spoke about a project called Scaphandra last week.
Yeah.
He said like one of the things that's difficult about this is that, like you said, the clock speed can go up and down. And the kind of mental model that I left the conversation with was a bit like revolutions per minute in an engine. So you can have it redlining to go really, really fast. But if you scale it right back down, then you can be somewhat more efficient, but there's going to be impacts. I didn't realize that you had that kind of control at a software level itself. Actually, you could deliberately, I thought you could only just ask the CPU for work to be done rather than say, can you do it? But because that's not like nicing something. That's a different level of hardware control.
Nicing is probably, no, it's not like nicing something. It's a very different level of hardware control. Yeah.
All right. Wow. We went really deep. Not expected enough. Okay. Yeah. Okay. So hopefully that should help the question that asked.
What was even the question? What was even the question?
Are there examples of measuring the SCI in pipelines? And the answer was yes. There are examples of it. There's lots in the open. The work from Green Coding Berlin is probably some of the stuff that's really in the open. But there is also work done behind various corporate firewalls that you might not be able to see, or you probably can't see, unless you employ all kinds of industrial espionage, which I suspect you're probably not going to do that if you are good at that. Anyway, okay, let's move on to the next question, Asim, because we're burning through our time.
Go on then.
Next question was about the carbon efficiency of GPUs. This seemed to be a question basically saying, what's the carbon efficiency or otherwise of GPUs when they're used for like onerous vector search and stuff like this? And is this good for the environment? This is the question that I got, and I assume this was a response to people talking about the fact that with this new world of generative AI and LLMs, you use lots and lots of specialized chips often, which look like GPUs or sound like GPUs. Do you want to have a quick go at this, Asim? And then I could probably bounce on some of this because
Let me say two things. A, if you're using a generalized CPU, which is specifically for generalized and for anything else, so it will be more efficient on a energy basis. I would say the point though is when you start using GPUs and you start using these specialized hardware, each of them has an idle power amount. And so if you've got a GPU and you've got a whole series of them, or all this the specialized hardware, and you're not using them, that's actually bad. And so it's very important when you have this specialized hardware, like you're thinking through and you're thinking, I've got it, I'm using it, that's why I've got it. Obviously, if you're in the cloud, it's a different equation, right? Maybe not actually, if you can just order a GPU and not really use it. And the other thing I would say is, and I've seen this conversation go a little bit wonky as well, is when oftentimes the total power of a system increases because a GPU consumes more power. And then people just say, oh, it's less efficient, it's consuming more power, without factoring in that like a job will run faster and therefore the total energy will be less, if that makes sense. I've seen conversations get into confusing territory and people have confused energy and power, because power is like just the, watts per second, whereas the total energy. So if you're using, that's another way.
You're talking watts versus here, right?
Yeah,
the idea being that you might have a GPU, a graphics processing unit, which is extremely energy intensive, but it runs a job for a short period of time, and then it could be turned off or could be scaled back down, right? That's the thinking. That's what you're saying, right?
I don't know if they can be turned off, but I think they're always on, aren't they? I don't know. Actually, I have no idea. But yeah, are there ones that turn off?
You can see there's a definite impact between something running at 100% and when it's idling. There is a change, but I'll be honest, I'm out of my depth when it comes to figuring out how many people who run data centers switch them off on a regular basis. I suspect the number is very low.
It's close to zero.
Yeah, I was actually going to answer this differently.
Go on then.
Going to see that if you want to talk about the carbon efficiency of GPUs compared to like CPUs or something like that, it's worth understanding that the emissions will come from two places when you're thinking about this. There's emissions created from making the actual computer, and there's emissions from running the computer. And when you make something which is specialized for like the GPU, for example, that's going to be pretty energy intensive. And in many cases, you have a bit of a trade-off, right? Where if you basically had a bunch of CPUs compared to GPUs, if the GPUs are more energy intensive to make, then if you don't use the machines very much, then you don't have much usage to amortize the kind of cost. So in that case, GPUs are going to be pretty inefficient. They're going to be pretty carbon inefficient. But for the most part, because these things are so incredibly expensive, they tend to get used a lot, or there is an incentive to use them as much as possible. And even if you're not doing them, to make them available for free for people to use these, or at least to try and grow a market. And that's what you see right now with things like various tools like ChatGPT and stuff like that, which lots of us are not paying for the use of that. It results to a massive amount because you want to achieve a certain amount of utilization so you can actually get any kind of return on this. The thing that I would actually draw your attention to, or the thing that might be worth looking at, is recently we had the conference Hot Carbon, and there was a really cool paper which was specifically called, which addressed this. The title of the paper was called Reducing the Carbon Impact of Generative AI Inference. There's a number of people who are named on this. So Andrew A. Chien from University of Chicago and Argonne National Laboratory, Hai Nguyen, Varshao Rao, Tristan Sharma, Rajini, oh my God, I'm so sorry for mispronouncing the name, Vijayawardana from the University of Chicago, and Liu Shushan Lin, I think, right? This was a really interesting talk, I think, because it was basically looking at the environmental impact of tools like, say, AI, and saying, okay, we've got this whole kind of trend of employing LLMs and large language models and generative AI in searches and things like that. What does the impact look like? And they basically looked at, say, the usage figures that were published for ChatGPT in March 2023. And that was like 1.6 billion, this. And then based on that, they modeled the likely inference cost, which is the cost from using it, and the training cost. And there was a few kind of takeaways. First of all, we often talk about the training cost as the big thing to be aware of. And they said, no, the training was 10 times the impact. And they said, if you were to scale this up to, say, Google's usage, then even if you had a training cost of about, that's going to have a ginormous impact, basically. So we should be really thinking about the inference part. And in this case here, having something like a dedicated fast machine that does the inference compared to a bunch of CPUs, for example, this paper is really cool for a bunch of other reasons.
And I just want to say, I think two things. With the increased adoption, interest, usefulness of AI, inference is going to go through the roof, as you said. The only place it's going to go is higher. The only place it's going to go is higher as the years go on. As I've said before, nobody invests billions of dollars into AI if it's not a growth sector. People aren't going to use it, and more people are going to use it. More, that's inference. That's why inference is very interesting. That's going really high. And I just want to say, look, I just completely forgot about the Hot Carbon conference this year. I watched every single talk in the Hot Carbon conference last year, and let's put it in the show notes because I think last year's program was amazing. I watched every single video. I made copious notes on all of the talks, and I'm looking forward to going through it again this year and doing what you did, Sounds, and just listening to all of them.
Yeah, dude. We had some of the people, we've had the speakers from the previous talks because there have been so many really good ones. The thing that I really liked, I just want to come back to this one because I think there's some really nice things that came from this talk in particular and this paper. One of the key things is basically saying, let's assume you're going to have this massive increase in usage. And I think the comparison was, they said, if you were to scale the usage of ChatGPT up to the kind of modeled usage in this paper for, say, like a mainstream search engine, a 55 times increase in use. If you were to scale it up that way, you might think, oh, cripes, that's 55 times usage, assuming this was like in 2030 and then this. They basically tried to project this forward into 2030 and say, well, okay, what would it be that in 2030 we would have 55 times the carbon footprint if you did this? And they basically they took some trends and extrapolated them forwards. One of them was that you're probably going to see an increase in energy inefficiency over time because we have seen in Moore's law.
So you said energy inefficiency. Did you mean
energy efficiency? Right, they basically said, let's assume between now and 2030, you see a 10 times improvement inference. And that's based on what we've seen so far in terms of things keeping getting more efficient. Let's look at the carbon intensity of the grid. We'll also be decarbonizing over time. And they took some from current trends and what's actually, especially been coming in with changes in policy. And they basically said, with these numbers, is it possible to do something about these figures? And what would the figures be if you were looking at this in 2030, in the next 6.5 years? And they basically modeled some of this, and they did this as a way to figure out the actual savings possible by using things like carbon-aware programming. And one of the key things they said was that because inference isn't super latency sensitive, because of the actual in the actual chips in some distant, say, machine doing a bunch of inference, then piping the results to you, it's not so latency sensitive. And that means that you can quite easily run this in lots and lots of greener regions, even if you're accessing it from a place where the energy is not so green. Just say, using this versus what we have right now, we're probably not going to have a massive increase. I think the figures that I saw for the kind of good scenario, they basically said, based on this, if we were to employ, let's assume you're going to have machines becoming more efficient anyway, and you scale up this much usage, if you were able to carefully run the inference and serve the requests from the greenest regions.
But that's the assumption. The assumption is that you have to actually be green, do green software to decarbonize a software. So it sounds like if you did everything we're asking you to do, we'll be flat. Do they have a number for what if people didn't do what they were supposed to do?
They basically said, assuming if you didn't have any energy efficiency improvements, they said 55 times load would be 55 times the footprint. They said, assuming you have the efficiency improvements increasing at the same rate as they have been, you're looking at maybe the emission with an uplift of 55 times the usage, you'd probably be looking at 2.5 times the energy usage. I mean, the emissions from the grid, right? Yeah. But they said if you were to actually use the carbon-aware programming like this, they brought it down. So like the ideal scenario would be you're looking at 1.2 increase, which is kind of mind-blowing.
Well, it's mind-blowing, but I think it shows how important the work that we're talking about is. It's like, actually, it was one of the really great talks from last year's Hot Carbon, which I loved, which was, I forgot, I'm going to apologize. I'm not going to remember which one it was, but it was talking about how projecting forward kind of compute growth and how green software was a way of being able to handle the additional usage and load of the cloud without actually having to build more servers. Because fundamentally, we are constrained at the rate with which we can actually increase the cloud. But the growth is growing significantly as well. So like being more efficient actually allows you to to deal with growth. So I think that sounds like what you're describing. So you have to be green. You have to use green software if you want a realistic chance of generative AI being as ubiquitous as you want it to be. Something like that.
I mean, the other thing is you don't have to assume that they have to be there. You don't. Maybe the option is you just don't need to buy all this equipment in the first place. These will never be a replacement for actually having better data.
What if they're just humans in a building that's answering your question?
Well,
is that more efficient? There was a Gartner thing I saw recently, which is that the total amount of energy used by AIs by 2025, so Gartner report, will be higher than the total amount of energy used by the entire human workforce in the world.
I don't know enough about that, and I feel a little bit wary about referring to that. But the point I was going to get to was the fact that you're seeing examples where actually just having good domain knowledge, it turns out to be much, much more effective than having loads and loads of compute. And the good example that I've linked to here is actually, there's a company called Lesan. They're based in Berlin, and they do machine learning specifically for Ethiopian languages. And they outperform Google Translate. They outperform some of the large providers because they've just got access to the actual benchmark data sets from the first place. This is the thing. Having quite high quality data is another way to reduce the amount of compute used. And this comes up in and again.
Yeah, very good point. Right? Yeah.
And this is also when you bear in mind that even just the whole tokenization that you have when you use it's based around English language. And so even another language is we're going to need more tokens for the same amount of sentences. So there's a whole bunch of issues there we might refer to. Yeah, all right. So we dived quite far into an efficiency of GPUs, and you might think about that. I think we've got time for maybe one more question left before we have to wrap up, Mr. Asim.
Okay. You pick it.
Okay. So this is a question about water usage.
Okay.
Can the cooling water for data centers be reused? And this is a question because people, I think one of the worries is that people actually, in many cases, it just gets pumped back into rivers when the water's that much hotter.
Yeah.
You kind of basically just cooking the fish, which is not, that's not very helpful.
Depends if you like eating. I suppose it depends if you like eating fish.
I don't think it's good. I don't think the fish enjoy this.
Okay,
right?
The fish enjoy
but
it.
Basically, that's one of the issues. But I think this is more actually a case of this is speaking to the fact that in many cases, one of the big things that's come up is basically people talking about the water usage associated with compute, and in particular, the data centers which are very heavy on generative AI and things like that. And there's a really good example that we might refer to that I learned about, which is Google and some of their data centers in Chile. Over the last few years, there was a whole thing where so in Europe, for example, where there's lots of water, you don't necessarily, or there's parts of North and Western Europe where if they're cold and they already have lots of water around them and lots of rainfall, then it's not so much of an issue. But if you were to put a data center where there's loads of drought that uses lots and lots of water, the examples, it's a company called organization called Algorithm Watch who spoke about some of this because you see protests against data centers. One of the key things was you find some data centers using something in the region of 169 litres per second. Now, if you run that in a place which has drought, maybe not the most equitable use of a scarce resource, especially for the people who rely on that water to live and survive. And there are other examples where large companies have come in where they've ended up using significant amounts of water. The thing that was interesting about Chile was that Google wanted to deploy a data center here. They had a bunch of pushback, but then they ended up choosing to use much, much less water-intensive technology as a result. Like I think it's adiabatic cooling, which is essentially a kind of closed-loop system, which doesn't rely on evaporating water, then getting rid of the water as a way to cool things down. This is one thing that came up, and I've added a couple of links to both Algorithm Watch talking about this, as well as the actual organization, the activists in Chile, talking about, okay, we had a victory for this. The fact that, there are issues around it, but it's also a case of in companies, they can make these choices, but a lot of the time they might not choose to because it's a little bit more expensive. And here you feel like if a company's could be making a huge amount of money, and Google spent $60 billion on by buying its own shares last year, they could have fairly efficient, less water-intensive cooling in a place where that's suffering from drought. This seems a fair thing. Like these things we should be asking for and should be setting as a norm. There are other organizations doing this too.
What do you think? One of the things, and I've got nothing to back it up, but one of the things that was hinted to me the other day, I think it was Sarah Bergman who might mention on Twitter, there might be situations where it's mutually the opposite. Being more carbon efficient might actually make you more water intensive. Like, for instance, doing things that reduce carbon emissions might require more water consumption. And which is why I think it's exciting that we actually are starting to have this conversation right now, because I think we're so focused on carbon and we're optimizing for carbon, but actually the landscape is much more complicated. It's much more of a surface where you're trying to minimize the environmental impacts of your choices. And you might have to make trade-offs versus one versus the other. If there's a water scarcity right now, you might have to increase your carbon emissions. I'm excited that this is where the conversation is evolving to, because once we add water to the mix, we can add other things.
You see a trade-off for sure, but and also lots of these, ultimately it comes down to capital expenditure. Lots of the
it can be an and.
which are very, very low. Yeah. Like you are saying this, but it's also worth bearing in mind that when you're looking at this, impact comes from the energy generation in the first place. Because let's say you're going to burn a bunch of coal to heat up a bunch of water, to turn it to generate some electricity, a huge amount of water being used there. In fact, freshwater usage in energy generation, I believe it is actually the number one source of water usage in America. So when we talk about this, it's also worth thinking about the entire supply chain. Yes, there are absolutely things you can do at the data center level. Also, if you look through the supply chain, there's also other areas. But typically with data centers, it tends to be very localized. So there may be water being used, but if it's water being used in a place where that people are depending on for drinking water in the same town, you can understand why people are a bit miffed, basically.
It's like we don't really think of data centers like coal power plants. But like it's almost just the same. Like we treat them as very different. But at the end of the day, like water is in this case could be a pollutant.
Yeah.
If you're pumping hot water out, I don't know. I do not know enough. Please don't quote me or anything. I don't know exactly what happens here. I do not think that data centers are like, maybe they are like squirting like jet hot streams of water into rivers or something like that. But I'm just pointing out that you often feel like some things are like abstracted away from emissions so much you don't really associate it with the entity. But like with a coal power plant, we just so associate it with emissions that we know what to think about it, how to think about it. But like a data center in a way it generates emissions. And so if it is putting like hot water into rivers and streams, isn't that a pollutant?
Well, yeah, there's all kinds of pollutants that you have. There's noise pollution as well. There's that you might need to take into account when someone's citing big pieces of infrastructure, because this is industrial infrastructure. That's the main thing.
Yeah.
And like there are cases of people having a really hard time with just the whirring and the noise pollution from data or crypto mining rigs.
Really? Yeah. Can you hear, if you lived there, you'd be able to hear whirring from...
I'll share a link to an example from... There's an interesting case with Amazon specifically, where there's a bunch of people who are basically complaining about the noise pollution in, I think it might be West Virginia, where they basically hear this because it's loud enough. But you also see this with cryptocurrency mining in New York State. There's been lots of cases where you have typically the really quiet, serene places where the calm has basically been punctured by the incessant whirring of all these things. God. Exactly. So there's various dimensions that you would need to take into account that go beyond just thinking about carbon and carbon tunnel vision. But let's be honest, dude, like most of the time, organizations struggle with just thinking about carbon as well as cash. Yeah. Right? So let's add
water and noise to it though, Chris. Let's give them everything. Yeah.
And what I'll do, I'll add another link because there's some really fantastic work by Sasha Lucioni, who's the client lead at Hugging Face. Yeah. She wrote a really good piece in Ars Electronica talking about all the various things you need to take into account with the environmental and social impacts, technology, and specifically AI. It's a really nice way in. And I should actually share, my organization published a new thing this week. A new issue of Branch has come out. And Excellent. It's got a bunch of stuff talking about this from Tamara Kanice. She wrote about some of this, but also Dr. Theodore Dwyer. She wrote a piece about. She's also an expert in. We'll share a link to that because that would be fun for some people as well.
Yeah.
Oh, blimey, we've gone way over actually.
That's good. That's good.
Okay,
great episode.
So we answered those questions, or at least we've peppered these show notes with huge amounts of links for people who might want to learn more about this, and hopefully we've added some tantalizing hints. Asim, I think we're actually at our time. We've got through 4 questions this time around. I think there are some more, but in the meantime, I think I'm going to have to say thank you for coming on and wandering through this with me. Yeah, this was fun, man.
Yeah, it's good to see you again. I love these mailbag episodes. Let's do more of them.
Yes, I want to ask you a bit more about the Impact Engine next time as well, because I didn't know about that.
Give us a month, and I'll be able to get into a lot more detail about it with you. Yeah.
Okay, cool.
Yeah.
Also, if anyone who's listening to this is curious and has questions of their own, please feel free to at us in various places, or even come to the new discussions, the new Green Software Discussions website. I might ask you to point to this, because otherwise I'm going to tell people about the podcast.Green Software Foundation address that we normally use. Is there
we
a
should create a short
address
link
for it?
We should create a short link, but there isn't. If you actually go to our GitHub organization, there's just a tab called Discussions. But you're right, we'll put it on our website, and we'll make sure it's more prominent in the future. Yeah.
Okay, in the meantime, go to podcast.greensoftware.foundation. Most recent episode will have a link to Discussions where you can ask some questions, and then we may, if we can fit them in the list, we'll answer them so we can add other things coming through.
Yeah, that's a great idea.
That was us. Lovely seeing you again. Hope the mushrooms are well. And see you on the flip side, okay?
See you then, buddy. Bye.
Bye. Hey, everyone. Thanks for listening. Just a reminder to follow Environment Variables on Apple Podcasts, Spotify, Google Podcasts, or wherever you get your podcasts. And please do leave a rating and review if you like what we're doing. It helps other people discover the show. And of course, we'd love to have more listeners. To find out more about the Green Software Foundation, please visit greensoftware.foundation. That's greensoftware.foundation in any browser. Thanks again, and see you in the next episode.